welcome to Ladyada.
Hey everybody, and welcome to my desk. It's Desk Ladyada. It's me, Ladyada, here at my desk with me, Mr. Ladyada. Mr. Ladyada has some news and updates.
Sure. So
tell me you want to get to. So
we moved the shows around last week, and then this week coming up, JP's going to do show and tell. Last week, Noah and Pedro did, and then we moved Ask an Engineer from Wednesday to Thursday because Ladyada met the mayor and the deputy mayor and a whole bunch of people in New York City. Adafruit was recognized for all of their work during the pandemic. And this is a cool glass award thing that we got. This is for our entire team. Thank you, everyone who works at Adafruit, the community, all y'all customers out there who supported us during all these times. Here is my blog post about it. We went to Gracie Mansion. Who knows if we'll ever get back there again or invited there again. Janelle Doris, Commissioner of Small Business, was there. Here's Ladyada, where the mayor lives. First up was Janelle Doris, and these are folks that we knew from the weekly advisory board that Ladyada was on. We met Ramona from Selmar. She makes metal doors.
She was cool.
Another woman-owned company. Melba was great. These are all people that we knew. A lot of these, if not most of them, were minority and women-owned businesses like us. And then Philip Thompson was there, deputy mayor. I really like him a lot. Also, MIT professor, so a little MIT theme here. And then the mayor was here, the video's there, and then there was a report supporting small business in NYC, recovery and growth. And for the folks out there that listen to mainstream news or whatever, so New York actually had a population increase, not decrease. So we're big back in Boulder.
8.8 million, right?
Yeah.
8.9?
There's a lot. Mm-hmm. So that's there. So you could check all this out. And then, of course, you could take the Ladyada out of the hacker scene, but you can't take the hacker scene out of the Ladyada. So we explored the basement of Gracie Mansion, and we found a payphone.
Yay!
So this payphone doesn't work. We did make sure we tried to operate it. It is completely disconnected, but I'm going to send this photo off to 2600 for their payphone back cover thing. If you've ever seen 2600, they have all these payphone covers on the back of the magazine. And so, anyways, there's that.
That's our picture.
Then we walked home, and I took some pictures. I got some black and white photos. If y'all are looking for
birds
art stuff now, I have my personal Twitter account, and I use Twitter improperly. So if you want to see art and some things behind the scenes from Adafruit and more, you could do that. I posted up this over the weekend. This is an email to Ladyada in 2006. I'm like, hey, that was a great night. You're going to be on the cover of Wire one day. And then 5 years later she was, so I put this on here. So I'm trying to document stuff, and I got stuff from my sketchbook, and then some behind-the-scenes things at Adafruit and more. So if you want to check that out, it's twitter.com/.
Your drawings are so cool.
The drawings are there. Look,
they're
soldering.
cool.
Look, someone's soldering.
Ooh.
It's my hand. So anyways, there's a bunch of stuff here. I have normal human bones, just so you all know.
Yeah, how are your bones?
Normal, human, and I have documentation to prove it.
Good.
So anyhow, that's what's going on here. And then this is Antonio, this friend of mine. And then here's Ladyada in front of Gracie Mansion. And there's Phil Thompson. And here's more Gracie Mansion stuff. So, when you have a black and white camera, you use it. So the other thing that's going on, Ladyada, is we are releasing our NFT gallery this week.
Okay, you guys, I know everyone here is watching has just been like, we know that Adafruit does NFTs, and it's true, we have an NFT gallery.
Yeah, we do.
Show them.
But let's be really clear. So we've never done NFTs, we never will. We don't do ETH and all that stuff. So here's our thing. So here's our statement, adafruit.com/NFT. You can also go there by adafruit.com/NFTs.
Yeah.
We're fine. There's nothing on Adafruit about NFTs. We do not have any ETH. We've never purchased an NFT or ETH. We've never minted an NFT, zero, nothing. We've been asked to participate. We've been asked to participate. We've always politely said no. And so we have a shirt that we work with the Share Zone to stock this in our store. And it says, I don't collect NFTs unless you're talking about nice effing t-shirts. And what we have here is the Adafruit nice effing shirt gallery. So everyone at Adafruit wears
they have great shirts,
amazing black shirts with skulls and comic book characters usually. So we've wanted to do this for a while, and because our team has been stalked and harassed, and people have been claiming we do NFTs secretly and all that. Jason Scott. I wanted to take photos of all this and have our gallery. And this
wasn't planned. This is just one day. You just checked with the people who are at Adafruit and were like, let's take photos of
And here you are in front of a NFT gallery in New York City. But they didn't have nice effing t-shirts, but you did. So anyways, we're going to be doing this. This is just like our Cats of Engineering page. If people have cool shirts that they want to send, they can send it to social media at adafruit.com.
So they can submit their own NFTs.
Yes, they can on the open sea.
And if you like any of these photos of t-shirts, you can just download them.
Yeah.
It's okay.
It's okay. So anywho, so this is, I forgot the URL. I think I just captured it. So we did this a long time ago. You can add your cat.
That's a nice gallery.
Yeah, you can add your cat. You just said, and this took off. And this was another thing that people were like, oh, all these people who say they have cats and they do electronics, they really don't. So then we started the Cats of Engineering gallery, and this goes on and on and on and on.
It's like a dopamine injection.
And on and on and on and on and on and on.
Oh wait, that's a cute one.
It goes on and on forever.
That's a cute one too.
Kind of like the shitty people on Twitter.
But this is like not doom scrolling. This is fuzzy scrolling.
This is fun. So anyways, and there's MOSFET in here if you look really close, our cat. So that's our cat.
I think we seeded
that's where we started. So anyways, that's what's going on. Ladyada, what's on your desk this week?
Okay, so we did a whole bunch of prototypes. So first up, I got my QT Py ESP. I'm kind of going to go in reverse order. So the QT Py ESP32-S2 panel came in. Folks remember I was working on this. I want to show some of the changes that I made from the prototype to the final version. You're going to learn lessons from what I got wrong. So,
want to go to the overhead?
Yeah, let's go to the overhead. Oh, it does not. It was like, why are you doing this? Let's put this pink feather. By the way, we're making more pink feathers.
We got pink feathers. I posted
it up. Coming soon.
I posted them up on the Adafruit Twitter account over the weekend. We've been going crazy on social media. And the reason is sometimes people out there say, you look like you're having too much fun over there.
We're having too much fun.
You look like you're bringing people together to do electronics and more. It looks like you're trying to make the world a better place with science, technology, engineering, art, and mathematics. And I'm like, yeah. And here's some pictures to prove it.
Okay. So these are the two prototypes that I showed off, I think, a couple weeks ago. So I made one with a small antenna and one with a UFL. And I think the UFL was the Great Search. And these boards worked, and I did a 2-layer board, and the 2-layer board worked fine, but I was a little a little anxious because ESP32-S2s use a ton of current, and the ground and 3-volt planes, they weren't, it's a 2-layer board, and there's a lot of signals too. We did have a good chunk for the ground plane, but I think especially the 3-volt lines, I wanted them to be a little bit thicker, and so I thought, for a board this small, let's go with a 4-layer. To get that ground and to get there's one full plane for ground and one full plane for 3 volts. And so the 3-volt power supply is nice and quiet on this board. Also did a nice silk screen thanks to Phil B. Moved a couple things around. One thing I learned, when I made this board, you can see that there's this one tall part over here. I put one of the 0805 10 or 22 microfarad capacitors on the bottom because I was like, there's a lot more space on the bottom than the top because the top, some parts have to be on the top. Buttons have to be on the top. The QT Py connector has to be on the top. The USB-C has to be on the top. The LEDs have to be on the top. And the regulator and the antenna I kind of want on the top too. And so I put the big capacitor on the bottom. But then I didn't like that it was sticking out. I kind of wanted it to be much flatter. So I did move that capacitor out. I moved, there was a couple 0402s, I moved them to the back. And then, we'll zoom in a little bit. No. Okay. Man, that does not like me. Hold on. Okay. I did move some 0402s to the back, and then I moved the 3 capacitors. There's 3 22 microfarad capacitors. You can see 1, 2, 3, and the NeoPixel on the top. So this is really I couldn't pack any more, even if I wanted to. And then the 2 buttons and the stub QT. But this one works fine. This is 4-layer board, and I was a little, not like nervous, but when I got the panel and I was like, well, you can't tell if it's 4-layer. Like, it's not like you can see the layers because they're so thin. So I put together a quick demo with one of the boards I put together real fast. Let's see.
I'm try to focus in on that a little bit. There you go.
Yeah, so this has got the QT Py board, a humidity sensor, and then, an OLED. And the OLED is, there's a very small text today. You can do it. So it's publishing data to Adafruit IO, and that's working just fine. And then the LED, if you want to do the computer real fast, I've got a dashboard where the data is being transmitted, and also there's a button. When I press the button, you see that little
reminder.
switch.
Everyone can do this for free. Adafruit.io. We made an IoT service for makers. We're talking to lots of other companies, and they're not doing free stuff. They're not having good privacy policies, and that's why we're going to continue to do Adafruit.io. And then if you're like, well, I want to use it for like a lot of things, and I hope you have some way to pay for it because I hate free services that go away, you could do an Adafruit.io plus account. And that concludes the thing I'm always supposed to say because I always assume folks know about it. Turns out they don't. So Adafruit.io. Yeah. What else you got?
Yeah. Okay. So next up, I'm going to disconnect this. It's confusing. So prototype came out fine. I'm going to get some of these boards fabbed. It's an experiment, but I think this seems to work. A small board running Adafruit IO seems to be, I'm doing a couple demos and it seems to be working okay. I think I'm just going to kind of release it because it's a little bit of a experiment. This is the first time I'm using the raw ESP32-S2 chips, but so far so good. I think the thing that I have to think about the most is just making sure the power supply is nice and stable because again, it's the Wi-Fi uses a lot of power, basically. Do
you want to answer a question?
Yeah, sure.
How do you do 2 passes on the pick and place?
You just do one. You do all the one sides, and then you flip the boards over, and you feed them in, and then you just put the stencil on the other side. And your oven is, your oven holds the boards above the heater. They're held by the edges, cool. So it's fine. It works okay. Okay. You just make sure whatever side you do second. Usually the second side has LEDs and other very temperature sensitive parts, whereas the first side is usually like the one that has capacitors and and passives and stuff, non-heavy connectors, and so they don't fall or get loose or get damaged.
Yeah.
Okay. So that's that.
Want to do the overhead again, or what do you want to do here?
Okay. So next up, I've got let's go to the overhead. So next up, I've got the Feather ESP. Sorry. So the Feather. Did the QT Py ESP32-S2. Next up is the Feather M4 adalogger. I think last week I talked about how I made a mistake in the power supply switching circuit. I used a high side PFET, which works fine as long as the device attached to the port over here was drawing less than 20 milliamps. Anything more than that, the power, or if you have more than a couple components, turning it on would charge up the capacitors, drooping this power supply and putting it into brownout. So I've replaced the transistor with a regulator. I also changed it a little bit. While I was there, I was like, well, you might as well make some of these capacitors bigger and stuff. But so far, so good. And I'm testing this with the SD card on the bottom. So the SD card slot is also separately powered, although that's not stressful because SD cards come up in a low power mode. So that is on a PFET. And just testing it out, it's on an SPI port because there's no SDIO pins available on this package if you use QSPI flash. You can either have QSPI or SDIO. I would think that people would want both, but I found that while I really love the 7051, the pin mux is a little irritating, especially if you're used to something like the ESP32 family where it's it's full crossbar pin mux. You can put any pin on anything, and you have so many peripheral choices, and you have a lot of pin choices as well, except of course the ADCs and the DACs. But you want I2S on these pins, go for it. Whereas the SAMD51 is very, very particular about what peripherals are on one pins. That said, so far so good. I've been doing some testing with it switching on and off one of these big ass PM2.5 sensors. This is like the biggest load you could possibly switch on and off because it turns on instantly. It has like a 5-volt fan over here. I mean, it's definitely a lot. So testing out that switching capability, and so far so good. I think this design is done. I'm going to send out the Feather M4, and then right now I'm just testing SD cards on SPI1. So if you want to go to the computer, I can just show the output. Cool. I've got these. I've got some small SD cards. I'm just testing them and making sure they work. And I like the SD-FAT library the most. I contributed to the original SD library, and then SD-FAT came along, and I was like, this is way superior. So I'm going to just test out a couple cards. I'm going to do a quick data logging example where it goes into low power mode. And then we might also tweak and work on the low power for the SAMD51. I think that I've never really cared about low power for the 51, but, even without much work, I got it, just basic deep sleep mode. Not deep sleep, but actually a light sleep where you can come back out of it and you still retain all your RAM and your registers and everything. And get down to 600 microamps, which is, not bad considering the ESP32, which is designed for low power, gets down to 50 microamps. So yeah, it's 10 times larger, but I'm not even trying yet. I think, I might be able to get down to 300 microamps. I haven't tried turning on the 32 kilohertz crystal and seeing if I can switch over to that. I haven't looked at turning on the DC-DC the buck converter. I put the inductor on there because, it's 10 cents and who cares. Might be handy. And, maybe putting that on and then going to deep sleep might save me, a little bit of power too. So I'm going to experiment with that to see how low I can get it. Because I want to make, this ultra low power data logger. And if I can turn off I2C and if I can turn off the NeoPixel, it can really run for a very long time. So that's good. So that's the Feather 4. Any questions about that?
Nope. Keep going.
And the last thing is just I talked I think last week about the CP2102N. I did make this version. I tested it. It works fine. If you are changing your design from a CP2104 to a CP2102N, like me, and you are like, wow, how do I program the LEDs? Because Silabs sold this chip to Cypress. The documentation is still on Silabs, but it's kind of scattered. There's a DLL, and the DLL wasn't updated for the N, and it's unclear, and there's a compiled executable, but it only runs on x86 Linux. Anyways, we did a video that you can check on the blog, and I found a fork of a fork, and in the issue of the fork of the CP2100X configuration app on GitHub, somebody made a version that has the correct EEPROM setup for the CP2102N, so you can set it up for the LEDs to blink, because I really like the RX and TX LEDs. I think that's a kind of a nice feature. Maybe I'll plug it in real fast and I can show it off. So if I'll just pop over my XCTU. So when I send data over, you see the red LED blinks.
Yeah, that's good.
Which I like, because I feel like it's data going through, and then if I jump for RX and TX.
If you have an LED and you're doing data transfer and it's not blinking, missed opportunity.
So that's red and green, and it looks yellowish, but both LEDs are blinking. So when data's coming in and out.
That's cool.
So that's good. I thought I couldn't get CP2104s, now I can, but they're not for 6 months. The good news is that if you design something for the 2102N 24 QFN version, and you add a 10 microfarad cap on like, I think pin 16, which is normally not used, and you just like leave that pad there, you can have a design that can use either the CP2104 or the CP2102N. And I think that's what I'm just going to do going forward is if I can't get one or, you know, whatever, you can swap them. And to be honest, the VID PID is the same. You know, for as far as software knows, you can't really tell the difference. The CP2102N just has reprogrammable EEPROM, and I think it can go up to 3 megabaud, and this can only go up to 2. So this goes 2, and this goes 3 megabaud. But like, you know, for most purposes, I wouldn't tell people to go above 1 anyways, 1 megabaud. So, yay, you know, find whatever chips you can get and use them. Okay, I think that's it. Do you have any questions before we go on
No,
to...
let's go to the great search. Ready?
Yes.
I'm going to play the video.
Yeah.
Where in the world is that part I need? The great search with DigiKey.
Great search brought to you by Adafruit and DigiKey. Thank you, DigiKey. This is when Ladyada shows you how she uses what I think is the best online component store in the world. Digikey.com, because they stock a lot of Adafruit stuff.
They talk a lot of stuff in general, including
Yeah.
the part we're going to talk about tonight,
So-
which is always great.
So the hard part is how do you find all this stuff? And Ladyada shows you every single week with the great search. Ladyada, what is the great search this week?
Okay, this week's great search is where you're going to learn from my mistakes, because I ordered the wrong part, and it was fine because DigiKey has a very generous return policy, so it's not a big deal. But wouldn't it be great to get the right part when you want to book it? And so in this case, I was looking for the ESP32-S2 chip for my new QT Py design. So let's go to the overhead. I'll show my design. So this design uses a ESP32-S2 chip, and the chip I want is, and this is the thing about Espressif chips, especially, you know, if you're using their modules and chips, they have versions that have built-in flash and RAM, but they look the same because it's like just bonded inside the chip, and you can't necessarily know unless you buy the right part. And another thing is the part marking may not be very clear. You really want to use Espressif's part selector in the data sheet. Just make sure you're ordering the right thing. So in this case, this chip is let me get the right part number when I say it. ESP32 dash.
Computer, or do you want me to stand that up?
No. You can stay here because I'll show it. So this is the ESP32-S2 FN4R2. FN4 means 4 megabytes of internal flash. R2 means 2 megabytes of PS RAM. But the thing is, if you look at the chip, which, you know, I don't think I'll be able to have it be too legible, but if you look at the chip marking, the R2 doesn't appear. I don't know if you can see it. I mean, I can barely see these before putting it under camera. But the marking on it is ESP32S2F. And, you know, I don't see the... Oh, actually, I do see the N4R2. Yeah, okay. Sorry. So the top part says ESP32S2F, and then on the next line below it, like 2 lines down, it says N4R2. So that's where you would see the flash and RAM markings. However, when I went to order the chip, I ordered the wrong ones. And if you, sorry, also as a note, if you look at this module, because I actually had to pull apart this module to get the chip, you'll see up here it says ESP32S2 Mini 1, and then the part that says N4R2 is at the bottom here. So it's not necessarily, like the part number is going to be split in two, and any of the bonded in flash and RAM are going to be on a separate line. Okay, so you learned that lesson from me. The next lesson is how do you know which one you want to get? And so let's go to the computer, because I want to show you.
Yeah, how do you know which one you want to get?
Okay, so one thing is that there's a lot of new Espressif chips, and the information in the chip, especially when there's internally bonded flash and RAM, it may not be in the DigiKey search, especially for new chips. So this the S2FN4R2. Again, 4 megabytes of flash, 2 megabytes of PS RAM. But if you look down here, the memory size shows the non-bonded flash and RAM. This is the stuff that's actually on chip, which is 120K RAM, 320 kilobyte SRAM. So that's the memory that's in the chip, not on the wire bonded, system and package data. So what you want to do is, I actually recommend going to the Espressif website and then under the chip, because they have so many variations now of every chip, and the ESP32-S2 doesn't have nearly as many variations as the just plain ESP32, which has like a bazillion, or they'll have every combo of flash, RAM, temperature rating. But if you go to the product selector, you can check the family. So in this case, I want to check the ESP32-S2. And then, hold on, I think that this is not, yeah, sorry, my computer is too low resolution. Just believe me. So down here is all the ESP32-S2 variations. And then let's say I want memory. So you can see here, it's like some chips have no flash and no PS RAM, but let's say I'm like, look, I want 4 megabytes of flash and I want 2 megabytes of PS RAM. And then when I go down here, I can find that this is the chip that I want to get, which is the, let's see, okay, here you go. You can see it. So down here you can see for the non-module version of the chip, the SoC version, it's in mass production. The part number is ESP32S2FN4R2. Now if I wanted a mini module or like, Wuru module, you scroll down on your computer, you'll be able to, oh wait, I can scroll. You can see mini, solo, we're over. Let's say I didn't want any PS RAM, so I turned the PS RAM to 0, and then you can see that there's a different version, and this is the version I bought by accident, the ESP32S2FH4. So, there's two versions basically, but each one is kind of called the ESP32S2F series. I think as long as you're aware of these, it's fine. So this is the ESP32S2FN4 with flash and PS RAM. And if you search for ESP32S2FH, you'll see that there's the FH2, 2 megabytes of flash, no PS RAM. The FH4, 4 megabytes of flash, also no PS RAM. And then the chip I wanted, the FN4R2, which they have in stock, which is actually kind of impressive. So if you want to make a design with built-in Wi-Fi and flash and PS RAM, it's pretty cheap. These are like $1.75, and they're in stock. And they're great for, just pick and place. And the component count necessary to get this running is really minimal. You just need a couple passives, 40 megahertz crystal, antenna, and good power supply.
If you could, for the folks that are just getting started in their engineering career, what's PS RAM?
Oh, PS RAM is, I think, pseudo-static RAM. It's basically, you have RAM on chip, usually, and that's, most of the time, whatever your microcontroller is has built-in RAM. Like the Atmega 328 using the Arduino Uno has 2K. The SAMD51 has 192K. But if you want a massive amount of RAM, like 2 megabytes, there's sometimes a peripheral on the chip, and this is usually on high-end chips only, where you can attach an external SPI flash or QSPI flash chip, an 8-pin chip, that'll give you slow but large amounts of RAM that the internal chip can address, and it thinks that it's like native. Very handy for IoT.
Is this like back in the day when hard drives would have like a RAM disk? and it's like, oh, we're gonna use your hard drive because we don't have enough RAM.
It's a little bit like a swap file, but it's not really. You're not using flash. It is RAM.
It's real RAM.
It's just
pseudo
off
RAM.
chip.
It's SPI. Right? It's a way to get to this other storage memory with SPI.
It's basically if you just want. It's because it's handled. Look, it's address. Look, historically you'd have 8-bit or 16-bit addressed RAM. All chips did because there's no internal RAM. And this is weird because it's like there's internal RAM and there's external RAM, and the PSRAM is just massive and slow. And so it's good for. It's not good for like you're running variables because in interrupts, for example, on the ESP can't use PSRAM. You have to use data that's kept on chip. But if you are like reading a JSON file from the internet and you want to parse it, and the JSON file is like 400K, no chip has 400K of RAM. And
so you toss it over there.
You put on the PSRAM.
And that's why we like it, because CircuitPython, we're putting all sorts of data on there. We got images, we got
it's
JSON
great
files,
for it's great for internet stuff because you can just slurp down the entire XML file and parse it. And because the internet's not designed for microcontrollers, people just stuff so much data in their JSON and XML files. It's like something like GitHub. You want to get stats for GitHub, you have to download like a massive file. It can be like 30K, and on a computer that's not massive.
What's funny is
that's not that massive.
Yeah, what's funny is like 30K is massive for microcontrollers, and like for computers when you
consider it light.
Well, for computers you go to like any web page now and it's like 300 megabytes because all this JavaScript is loaded.
Yeah, that's like the index,
Yeah,
is
like
300K.
here comes a new framework.
So yes, that's why I like the built-in PSRAM, and thankfully it's now available. So I just picked some up.
Okay,
and you should too.
And that's a great search.
Where in the world is that part I need? The great search with DigiKey.
All right, good questions. Thank you so much, everybody. I hope you enjoyed Desk of Ladyada. Don't forget we have our shows during the week. Tuesday is JP's Product Pick, live broadcast from Product Page. Wednesday is 3D Hangouts, Don Pedro, and then Show and Tell. That's going to be JP hosting. We're going to be doing Ask an Engineer on Wednesday. Thursday, JP's Workshop, and Friday, Deep Dive with Scott. And once again, thank you so much, everybody, for supporting us. And, it's not just the orders, and it's not just, stopping by the chats and everything. There was a lot of really nice people that
everyone's so
sent some thoughtful emails. People stopped by on different shows, and they were really rooting for us to get through the last 18 months. And the city noticed, and we helped. We made face shields, and we did medical devices for lots of different things that were needed early on in the pandemic. And it was really nice to meet a lot of other business owners, and mutual shared grief, but also joy that we have a shot. And New York is the toughest, grittiest place. I know it's not for everyone, but it's definitely for us. And I just wanted to say thank you to everyone out there, because we did Desk of Ladyada all that time too. And,
we did, and that's kind of why we kicked it. We started it because we were like,
we wanted to restart it. And there was people who said, I got a lot going on. I lost family, whatever. But every single week I watch these shows, and they mean a lot to me. So I'm like, we can't stop doing these. We got to do them every week.
We're doing them.
Okay, everybody, that's it. We'll see you during the week.
Thanks, everybody.
Bye-bye.